Eldrigo Namaskara. Thanks, Gopiji. Namaste to all. Today we are connecting to an interesting guest, Jonathan Crabtree from Australia. You can look up for him on YouTube, and you will get a series of videos on Bharatiya mathematics. In a particular video on the death of arithmetic, Jonathan concluded by saying, "Make your life count with love as your measure. Then kids will climb trees with views they will treasure." Jonathan is with us to talk on treasures of Bharatiya maths. Let's all listen in. Jonathan, welcome to our weekly Samvad. Over to you.
Thank you very much. I am very honored to have been invited to share my knowledge with you, and I hope that I will be able to give you a very interesting talk. I am very passionately interested in the story of Bharat and ancient India. It's a wonderful story and it really needs to be told. My passion really has always been mathematics. So I'd like to just start off by talking about three big ideas in this talk. So the first question I have for you is just ask yourself, what does -7 minus -4 equal? It's a typical sort of question that confuses a lot of people, and it doesn't come easily when we start to think about negative numbers, even though they were made very simple by India a very long time ago. So the first big idea that I'll be discussing is about how I have rebuilt mathematics from zero. And the second big idea is all about the need and the benefit of teaching better Bharatiya maths. So let's get into it. You can see on this slide here just some examples of the languages that I've explored over decades. On this one slide, I don't expect you to read anything, but there's Greek, Arabic, Latin, Italian, German, French, English, Spanish, Dutch, Sanskrit, Swedish, Chinese, Hungarian, Czech, Hebrew, Danish, and Russian. So I've explored the foundations of mathematics across many, many cultures, thousands of books and manuscripts. And it has literally taken me 38 years so far. Most importantly, about 7 years ago, I really started to dive deeply into the Sanskrit of Brahmagupta. And what we're looking at here are the shlokas from chapter 18 of Brahmagupta's Brahmaspita Siddhanta. And these are verses 30 to 35. Here, we're looking at a slide of Brahmagupta's 5 addition sutras. I would like to highlight addition sutra number 3, because we're going to have a look at that sutra in action. So we might typically have a question like -3 plus +7 be discussed in class 7. The British gave us arithmetic, and I have replaced arithmetic with something called podometic. So the podometic goals for Bharatiya maths are to have guided object action learning stories. And these stories are an outcome of my exploration of ideas from Aryabhata, Bhaskara I, and Brahmagupta. So I'm suggesting that what currently is taught around the world in class 7 in Bharatiya maths can now be taught in class 1 or class 2. So the Bharatiya maths curriculum is about 4 to 5 years more advanced. So how do we do this? We do it with cartoons because children love cartoons. And so the early years of the mathematics education are all about entertaining and enter-training the children. So in class 1 and class 2, children can play the happy Harappan, positive and negative brick and hole game. So there's Poto the puppy has just popped her head out. Now, if you look at this picture, there is what I call ground level 0, which is represented by the grey circle on the ground. And Poto the puppy digs holes and makes bricks, just like in the Indus Valley civilization during the Harappan era. So there's Poto the puppy. And you should know that Poto the puppy was my own puppy. And so I thought that all children love puppies, children love cartoons. So I combined the two for a new way of approaching mathematics for children. But what we do is we teach the mathematics via very simple, visual, obvious visual ideas of bricks and holes to solve -3 plus +7. What Poto did is she had a stack of 7 bricks and she dropped them into a hole 3 deep. And the result of that was a stack of bricks being visible 4 high above the ground. So children can start to do additions across both negative and positive. And that was based on Addition Sutra number 3. If we continue on, the next most important sutra is Addition Sutra number 4. When positive and negative are equal, the sum is 0. The origin of the Western number line. There is the original page from this book by John Wallace in England from 1685. And in that diagram, you can see the very first concept of a number line. Unfortunately, on this number line that was in this book of John Wallace, he introduced a very, very bad idea. And in this story, the soldiers were at point A, and the soldiers marched 5 yards from point A to point B. They retreated 8 yards to arrive at point D. And so in that entire trip, the soldiers marching had traveled from A to D. So first they went from A to B, then they went from B to D. And from the entire march, they had traveled from A to D. And yet John Wallace then said that the distance that they had traveled from A to D was less than nothing. And so we got the very strange situation where real magnitudes began to be described as being less than 0. So there's the silly diagram in full detail, and you can read that in detail from the downloaded slideshow. But let's compare that with the very simple, what I call B lines for basic integers of Brahmagupta. And what we see here is when the number of positive and negative quantities are equal, the sum is 0. So Brahmagupta never said negatives were less than positives. Neither India nor China ever said negatives were less than positives. In ancient China, they had a concept of yin and yang. And India had similar concepts as well. So what we start to see is some symmetry appear where 0 in the middle is the sum of equal and opposite quantities. So you can define 0 as 3 positives and 3 negatives, where -3 and +3 are equal in magnitude but opposite in their nature. So we can then have a look at Brahmagupta's 5 subtraction sutras, the grammar of mathematics. People have for many, many years been saying that mathematics is a language. And if mathematics is a language, then mathematics must also have its own grammar consistent with language. And so Podometic Bharatiya mathematics is very much concrete mathematics. It's very much for the real world, as opposed to arithmetic, which emerged as a series of abstractions from ancient Greek philosophy. So here, if we look at the grammar of Podometic, it aligns with logic. It also aligns with computer code. So we have adjectives, nouns, and verbs. And if we start to explain mathematics with the correct grammar, things start to become a lot more intuitive and easy to understand. If we look at multiplication, we can see that, again, that has a slightly different syntactic structure, but we still have adjectives, nouns, but this time we have an adverb, which is a count of actions of addition or subtraction. So let's ask that question again. What does 7 negatives minus 4 negatives equal? I've changed the question. Previously, it was what does -7 minus -4 equal? But the language was wrong because -7 is adjective, adjective. So that question is adjective, adjective, verb, adjective, adjective, which is impossible to decode and understand. So we put nouns back into the grammar of the language of mathematics, and then what does 7 negatives minus 4 negatives equal? Little children have no problem answering 3 negatives because we now have the correct grammar to go with our concrete mathematics known as Podometic Bharatiya maths. And here, if we use black squares to represent holes, we can have -7 minus -4. Very, very simple. There are 7 black holes there. Let's take away 4 black holes, and we see with our eyes 3 black holes remain. Now, if you notice the way that I have written that equation, you'll see that for positive and negative, I use superscripted symbols. For the operations of addition and subtraction, I use normal case symbols. So here you can see that the negative sign is raised up a little higher than the sign of subtraction, so we know how to read the equation with the correct understanding. So 7 negatives minus 4 negatives is simply 3 negatives, and we now understand that instantly, even if we're in class 1 or class 2, although that would later on be class 7 if we were learning it the traditional way. So what is -7 minus +4? So what we do is we now can turn to Brahmagupta's subtraction sutras, and we see subtraction sutra number 5 when a positive is to be subtracted from a negative. So we've got a +4 being subtracted from -7. So we then just follow the ideas behind subtraction sutra number 5. Here we've got 7 negatives, which children in class 1 and 2 and 3 would just imagine were holes. And we've got 7 holes, and we have to take away 4 bricks. Well, you can't take away any bricks. We don't have any bricks. We've only got 7 holes. So in the Happy Harappan game, what we do is from ground level 0, we dig a hole and we start to build some more bricks. So we dig 4 negative holes to make 4 positive bricks. So we've dug 1 hole and we've made 1 brick. And this is what is known as a 0 pair or a balanced 0, which is 1 negative and 1 positive, according to Addition Sutra number 4. So we've dug a second hole and we have a second brick. We've dug a third hole, we have a third brick. We've dug a fourth hole and now we have a fourth brick. Now we realize that from our original 7 holes, we've added 0 in the form of 4 negatives and 4 positives. And according to Addition Sutra number 5, whenever you add 0 to any number, that number remains unchanged. So all of these ideas that Brahmagupta documented are beautiful. They are simple and they are complete and they are advanced, but we can now start to teach them to young children. So we've got, and there is the Addition Sutra number 5. So we started off with 7 negatives and wanted to take away 4 positives. We didn't have any positives, so we added 0 in the form of 4 negatives and 4 positives. And guess what? Now we can take away the 4 positives and we see that the result is 11 holes or 11 negatives. So let's turn to one of the most difficult concepts in mathematics, and that is, why is the multiplication of 2 negatives a positive number? So this would usually appear in class 8 to prove why -1 into -1 equals +1. But you might have guessed that in the Bharatiya maths curriculum, we're going to explore this in class 2 or class 3. Now, can you imagine children in class 2 or 3 understanding the proof of why -1 into -1 equals +1? It's almost unbelievable, but I'm going to share that with you in a few moments. Here's multiplication sutra number 2. The product of 2 negatives is positive. Now, I'm going to give you the class 8 explanation, and it goes like this. But what I'm going to do is to just explain to you what negative into negative actually means. What's going on? Well, when you've got -a into -b, it actually means -a subtracted from 0 b times. So when we have -1 into -1, what's actually going on is it's -1 subtracted from 0 1 time. So we know that Brahmagupta defined 0 in law Addition Sutra number 4. When positive and negative are equal, the sum is 0. So on the left, we had a 0. We took away the -1, and all we see is +1. Therefore, -1 into -1 as positive 1 is just a consequence of, from ground level 0, digging and creating 1 hole and 1 brick. Taken away the hole and the 1 brick remains. And the children will be able to understand that from playing games and reading the storybooks with the cartoons. It's no longer necessary to teach -1 into -1 equals +1 in class 8. We can now do that with cartoons and the happy Harappan brick and hole game in class 2 or class 3. So, as the lady says, that's too easy. What we can also do is we can rebuild maths from physics. And it's been said, God created the universe from nothing, from shunya, from 0. The text at the bottom, wherever opposing quantities or forces are equal, you will find 0. And that's as per Brahmagupta's definition of 0. So imagine here we've got planet negatron, the black planet negatron, and we've got a red planet, planet positron. And imagine that we're halfway between those two planets, and they are of equal mass and they are of equal distance from us. And if we were exactly between those two stationary planets, we would not move because the forces of gravity pulling us from either side are equal and opposite, and so the forces cancel each other out to 0. So Brahmagupta's definition of 0 is consistent with the laws of physics. If we just contemplate the Big Bang, it's as if shunya was decompressed, creating infinite magnitudes and multitudes from 0. And we have modern cosmology, we have modern physical theories about the zero-sum universe. It's pure Brahmagupta. We've got the physical theories and principles of the conservation of matter and energy. We have the principle of Newton's third law. For every action, there's an equal and opposite reaction. Well, in Podomatic, what the children experience is for every operation, there's also an equal and opposite operation. So children learn how addition and subtraction and multiplication and division are completely working back and forth. Now, we also have the ideas here just listed, the ideas of Brahmagupta and Bhaskara. And the principle of Podomatic is based on symmetry. And the universe seems to have a lot of mysteries revealed when we discover the missing symmetry. And all of these ideas of the shlokas, the Sanskrit, and the laws of physics have all come together into a purely simplified curriculum that I've called Podomatic, which replaces Western arithmetic. So, when we teach better Bharatiya maths, did you know arithmetic dates back to 300 BCE, and it's really what the British Empire took and spread right throughout the world. Yet 1,000 years after arithmetic really was established in ancient Greece, the Bharatiya maths was pretty much finalized in Bharat, in ancient India. And unfortunately, the ideas of arithmetic from the British Empire, they were updated wrongly ever since the Renaissance. Podomatic has been updated correctly since the 18th of March 1983, which is when I began this project. We'll just turn to the philosophy of the mathematics education system around the world, but in particular in India. So we've got, imagine that education is like a tunnel. You enter the tunnel in your first year of education of mathematics. And then every year you progress through that tunnel of that education system. Now imagine that all of the knowledge was in the form of light. we want to be enlightened in how mathematics works. So imagine that we shone the light of knowledge through the tunnel of mathematics education. I've pulled it apart so you can see what is going on in this model. So we shine the light through, and year by year, we can see that the bad ideas taught in mathematics classrooms around the world mean that less and less of that light of knowledge passes through from year to year. So by the time the child gets to the end, they've been muddled by laws of sign, they've been confused by number words, they've had the wrong ideas about integer ordering. It's been all about rules, not reason. Negative numbers have confused them. The indexed laws are crazy. They have the wrong ideas about multiplication, making more. And the end of the process after 8 years of education is that the child ends up with an obscured math mind. So if you look at the brain at the end of 8 years of mathematics education and look at how much light of knowledge has been shone on that child's brain, you can see that there's not a lot of that brain that's been illuminated by the education system. And so that poor little boy there has been abandoned and has a fear of Western mathematics. One of the issues is that India is likely to repeat the mistakes of past centuries if it just keeps on teaching the same Western ideas. So quickly we turn to arithmetic as developed as British maths, and we can test the teaching of addition, subtraction, multiplication, and division with positive and negative 12 and positive and negative 4. So there are the various combinations of sign with those integers. And we want to ask ourselves, do British origin school maths lessons pass the common sense test? And the answer is no. So if we look at all of the combinations in this maths matrix of addition, subtraction, multiplication, and division, with all of the combinations possible, we can see that I have graded each of the lessons involved with either green for a pass, yellow for a fail, or you can even see there's one cell there in the maths matrix which is grey because the West doesn't even try to teach positive 12 by negative 4. They do not have a model to explain it. And yet there is a model, as you will understand down the track in Podometic Bharatiya maths. So arithmetic fails because it wasn't built from zero. It came from the Greeks, who didn't have 1 as a number. They didn't have 0. The ancient Greeks didn't have negatives. And that's what the British were using to develop their mathematics education system. They exported and forced upon all of their settlements and colonies. So I just quickly turn to the outcome for this. And here we've got a PISA 2018 worldwide ranking. And you can look at this when you download the presentation. But you can see in the yellow at the very, very bottom of the world ranking appears Tamil Nadu and Himachal Pradesh as the worst educated students in the world for mathematics for 15-year-olds. This is a little easier. If we look here, here's a newspaper report. Indian students rank second last in a global test. And there's a link where you can download all of the research that was done by the OECD. How is it that India invented 0 as a number? Brahmagupta gave us all of the laws of negatives and positives and 0 for those combinations of the operations. And India is performing almost bottom of the pack. It is saying to me that India has intuitively rejected the Western mathematics. So why not revive the original mathematics, which is logical, correct, and consistent, that agrees with the laws of physics. So here are the results. So in Tamil Nadu and Himachal Pradesh, only 15% and 12% of students are ready to use mathematics in ways that are considered fundamental for their future development. So look at those numbers. For India, 15% and 12% are ready for mathematics at the age of 15, and the OECD average is 75%. India needs drastic action. Tinkering is not going to do anything. What India needs to do is to become a Vishwaguru again by using the most modern mathematics curriculum in the world, which is Podamedic Bharatiya maths. So here we can see now, if we have Podamedic as the curriculum, it's common sense, it's multisensory, it's intuitive, it's based on playing games and reading stories, and we can see that the child's mind is completely enlightened with how mathematics was intended to be understood and taught by India's great gurus and rishis. So let's stop the child abuse. Let's stop teaching the British maths in the primary level classrooms and start to teach Podamedic Bharatiya maths in the first 8 years of a child's formal education. So here, for completeness, there's the maths matrix with all of the cells now understood and easily taught in the classroom. So the British ideas of zero, positive, and negative are false, and the ideas and explanations of zero and positive and negative from India are true. So I think I might finish on this slide and simply say, let's save your schools time, effort, and money and embrace Podamedic Bharatiya maths. Thank you very much. Here's my vision for the future. Let's have children in India wanting to build quantum computers. Let's have them managing teams of AI designers. All of this is able and very, very likely to happen quickly should India get with the program and let me help develop the curriculum, work with NCERT, work with the Ministry of Education. It's my mission to help India become a Vishwaguru again in mathematics. Thank you very much for your attention. Thank you.